This is the buck boost converter with resonant circuit, that is LLC resonant circuit. Here this is the inductor, resonant inductor, and this is the capacitor, and here we are using a coupled inductor. Okay, so here at primary the resonance will take place, and secondary also we are using one L and C. This is L, this is C. Okay, and here we are using two switches in the place of rectifier. Two diodes and two switches are used. Two switches are used for active control. Okay, in primary it is half bridge, so two switches will be used, and we are providing supply of 12 volt 1 amps to this primary. From that we will get the boost operation and buck operation ranging from 6 volt to 18 volt. And for that we have to control the pulses. This controller will control the pulses depending upon the reference value. Here we will vary the reference value using this variable resistor. Okay, that 5 volt supply is taken from the controller and giving it to the resistor, and that signal, okay, how much voltage will be there, that will be provided to A2. Okay, so from this we can vary the pulse width, and from the variation of pulse width we can control the voltage. For that we need to provide supply for the Arduino and also for this driver ICs. Here for Arduino I have taken a separate supply, and for driver ICs I have taken separate supply. Here this is the transformer, 9 volt transformer. From this 9 volt transformer we are providing it to rectifier. We will get a rectified output. That rectified output will be provided to regulator. Here 12 volt regulator, here 5 volt regulator is there. 5 volt regulator is for this NOT gates, because here S1 and S2 are complement to each other, S3 and S4 are complement to each other. So we are using two NOT gates for S2 and S4. We are generating two pulses for S1 and S2. So here this 12 volt is provided to this regulator. From the regulator supply it is given to the each driver ICs. 4 switches are there. For each driver ICs we are providing 12 volt supply, and for this NOT gates we are providing 5 volt supply. For that separate rectifier set is used, and for this buffer IC we need 5 volt supply, that is taken from the controller. Here 5 volt supply is available, that is taken from the controller and provided to buffer IC. Here from the controller pulses will be generated and provided to the buffer IC. Buffer IC will protect the controller from the driver IC ripples, and also it will boost up the pulses without any transients or any ripples or any disturbances. That from buffer IC output we will provide to the input of the driver ICs. Okay, the driver IC will provide the pulses according to the input pulses. When input is on, output is also on. When input is off, output is also off. That is